Advanced Math, Lesson 2.5 notes. Solving radical equations. Steps. Step 1, isolate the radical. Step 2, undo the radical. It's going to make more sense when we actually do a problem. Step 3, solve. Step 4, the step we all love, check. Alright, I am going to highlight the check because that's a step that most kids feel like, I don't need to do it. I know I did it right. I'm 100% I did it right. I'm that smart. I'm that good. I don't need to check my work. This check is not to check your work. It's to check for extraneous solutions because it does happen. Kind of like those restriction problems that we've been doing where we find our restriction and then we check it to our answer. Kind of like this where you can do all your work correctly, but it doesn't work because it's one of the restrictions, which is not the case on this particular problem, but we've talked about it before. So that happens here as well. There's no restrictions we find in the beginning. We just check our final answer to make sure that it is correct, that it's not an extraneous solution. All right, solve. Number 1, the square root of 4x plus 9 equals 5. All right, step 1, isolate the radical. Here's the radical to square root. It's by itself. There's no plus or minus on the outside. There's no coefficients out front. It's isolated. Step 2, undo. We do that by doing what to both sides? Squaring. And when you square, that's the inverse of a square root, so they undo each other. And you're left with 4x plus 9 equals 5 times 5 is 25. And step 3 is solve. So go ahead and do that now. Subtract, divide, and get your answer. Oh, and there's one little piece I left off. I apologize. It doesn't change any of our work, but just add a little squared inside there if you would. That's 4x squared. Again, it doesn't change anything I said before about isolating, squaring, undoing, but please add that little squared. All right, now go ahead and solve. All right, x squared equals 4. We know that we square root both sides when we're solving. And like I stated in another lesson, you plus or minus when you square root both sides. So x doesn't just equal 2, it's plus or minus 2. Now, I'm not going to be the check your work police and like looking for your check work because some of you can check it in your head, which is perfectly fine. How will I know if you're checking? If there's an extraneous solution, which means you shouldn't put it in your answer column and you put it there, then I know you didn't check your work. All right, so let's check 2. 2 squared is 4. 4 times 4 is 16. 16 plus 9 is 25. And the square root of 25 is 5. If that was too fast, you can pause it and actually plug it in. I will plug it in for the -2 just to show you. And when you're checking it, you always plug it into the original. Before you moved things around, before you squared both sides, original problem as it was printed on your paper. -2 times -2 is 4. 4 times 4 is 16. 16 plus 9 is 25. Square root of 25 is 5, which equals 5. It's good. Both answers are correct. There's no extraneous solutions. All right. Number 2, the square root of 3x plus 7 equals 2x. All right, step 1 is taken care of. It's already isolated. Step 1 is taken care of. It's already isolated. Step 2, undo the radical. We square both sides. I'm going to put this in parentheses. Square roots and squares undo each other. They're inverse functions. 3x plus 7 equals not 2x squared, but 4x squared. So I can see where I'm going to have to get everything to one side. So I'm going to write it like this. 0 equals 4x squared minus the 3x minus the 7. I know to do that because of the squared, which means I'm going to have to factor to use the zero product property. Go ahead and hit pause and try to factor on your own. All right, I have it factored, 4x minus 7, x plus 1. Set them both equal to 0. X equals 7/4, comma, negative 1. Added the 7, divided the 4, subtracted the 1. Okay, and then you go ahead and do your check work. Plugging in 7/4 is a little bit harder, not as easy to do in your head. I am going to do it quickly because I don't want to take up too much time. So if it's too quick, just hit pause as we go and follow along. All right, plugging in 7/4. 3 times 7/4, nothing reduces, so it's 21/4. Plus, I'm going to rewrite that as 28/4, so they have a common denominator. I multiplied top and bottom by 4. Equals reduce 7/2. Add, that becomes 49/4 with the square root, equals 7/2. The square root of 49/4 is 7/2, which equals 7/2. All is hunky-dory and great in the world. 7/4 is a solution. Now kids will say, wasn't there a plus or minus there? No, you only put plus or minus when you square root both sides to solve an equation. All right, next one. Square root 3 blank plus 7 equals 2 times blank, and this time I'm plugging in the negative 1. 3 times negative 1 is negative 3. Negative 3 plus 7 is 4. And the square root of 4 is 2. 2 times negative 1 is negative 2, and 2 does not equal negative 2, which means negative 1 is indeed an extraneous solution. So that's how I'm going to know if you are checking. You're taking the test and you give me both of these answers, it's wrong, because negative 1 does not work. It is not a solution, it's extraneous. All right. Now you may think, well, I'm not going to check here, but I'll check on the test. If you're not checking now, you're going to forget to check on the test. Okay, number 3. 3 4th root of x plus 3 equals 9. All right, isolate the radical. Do you see how there's a coefficient there? I do want to get rid of that. I'm going to divide both sides by 3. That gives me the 4th root of x plus 3 equals 9 divided by 3 is 3. Step 2 was undo the radical. Instead of squaring both sides, I am going to raise both sides to the 4th power, because that's the 4th root, not the square root. The 4th root and the 4th power undo each other. X plus 3 equals 3 to the 4th is 81. Subtract your 3 and x equals 78. Let's check it. I'm just going to do it here. 78 plus 3, 78 plus 3 is 81. The 4th root of 81 is 3. 3 times 3 is 9, which equals 9. Check, we're good. That answer is not extraneous. It truly indeed does work. All right. This next one is a bit longer, and I'm going to go through and try to explain the best I can. The square root of x plus 5 plus the square root of x equals 5. Not sure if you saw these in Math 2 or not. Do you see that I can't isolate the radical? Because there's two of them. How do I isolate if there's two radicals? I can't combine them. They're not like terms. What I would suggest is you isolate the bigger one. So subtract that guy over to the other side. And that's the best we can do on this problem. All right, equals 5 minus the square root of x. And I do what I've done before. Step 2 was undo, and I do that by squaring both sides. Now, I've been saying this like the whole first 2 weeks of school. I'm going to clean this up first. On the right-hand side, that you cannot distribute the exponents when there's a plus or minus sign. That's a 20, as tempting as it is to say, oh, this is 25 minus x. That is wrong. Do not do that. They'll say, oh, 5 times 5, the square root undoes each other. That is not right. Not right at all. Remember, you have to write it twice and FOIL. Yes, we're going to FOIL with a radical. All right, so I'm going to take that part slow. I'm not going to do any shortcuts here. 5 times 5 is 25. 5 times negative root x is negative 5 root x. Negative root x times 5 is again another negative 5 root x. A negative times a negative is a positive, and root x times root x is either root x squared, or hopefully you can see that it is just x. All right, these are like terms. They don't cancel out because they are both negative. X plus 5 equals 25 minus 10 root x plus x. Now we're going to go back to our steps that we had earlier. We just finished the undo the radical, and now we're going to try to solve. But do you see that there's still a radical in there? Since there is still a radical, we have to go back to step 1. So this process is happening more than once. We have to isolate that radical again. So I'm going to subtract the x, subtract the 25, gone and gone. X minus x is gone. 5 minus 25 is negative 20, equals negative 10 root x. I'm now on step, still on step 1 where I'm trying to isolate. So I try to, well, not try to, I do divide both sides by negative 10. Negative 10 reduces, and that gives me positive 2 equals the square root of x. This part is easy. I square both sides. 2 squared is 4, so x equals 4. And if you check it, 4 plus 5 is 9, plus the square root of 4, we're going to check it, that equals 5. Square root of 9 is 3, square root of 4 is 2, and that indeed does equal 5. So 4 is not an extraneous solution, it works. All right, we do have one more, but the bell's about to ring to start class. So what I'm going to do is I'm going to label this part 1 notes, and I will finish recording at the end of the day part 2. And the part 2 will only have one problem. It is a longer problem. I'm going to show it to you really quick. It is a bit longer and takes a little more work to get through, but I'll walk you through it later. So part 1, and then you can watch part 2 when this is done to see number 5. That's it for now.